This project presents a semantic framework for the Aachen Cathedral Choir Hall. The challenge lies in bridging the gap between this millennium-old heritage structure and modern digital assets. We aim to transform the analog documentation from 1994 into an intelligent, semantic knowledge graph. The workflow begins with a geometric foundation. Initially, there was just raw chaos. Processing over 40 gigabytes of laser scan data meant navigating through billions of unorganized coordinates to locate the true structural boundaries. The goal? Turning that noise into structure. Guided by the 1993 archival drawings, 762 parametric timber beams were reconstructed in Blender. Next, activating the archives. Take a simple 3D beam. Visually, it works. But digitally, it's a blank slate without a name. It needs an identity. Assigning a unique URI creates a digital DNA, connecting the geometry directly to the semantic web. Then, there's the paperwork. 52 pages of physical damage logs, scan tables full of critical ratings, were fed into the pipeline, transforming into digital structure. Thousands of messy rows, cleaned and organized, linking it all together. Suddenly, a specific crack isn't just text. It becomes a node in the network, permanently linked to its beam. But what about the stories? Historical books often describe damage in vague, human terms like rotten beams in the north corner. We need to parse that. Through OCR and text mining, paragraphs turn into precise data points, dates, locations, and damage types. Knowledge fully linked. This creates a semantic bridge. Even without explicit IDs, historical events are now machine-readable entities, ready to be mapped to the 3D space. Now, the hardest part, alignment. The data was fragmented. Here was the conflict. 762 modeled beams versus 785 damage records. We had 14,000 triples from IFC and nearly 16,000 from Excel. We needed ID synchronization. Look at the JSON object. We aggregate distinct attributes, geometry, and damage under a single corrected ID. This is what we call strong alignment. We successfully linked 92.5% of the components, creating a solid digital baseline. But then the data gaps. Some records just say, repairs on the eastern half. No ID, no labels. The system was blind here. Enter spatial reasoning. We defined spatial scopes such as whole roof, eastern choir hall, leading to weak alignment. In this JSON data, the algorithm takes a vague tag like east and automatically captures all beams in that zone. Finally, the last phase, visualization. Data shouldn't stay hidden in a database. So, we built a custom web viewer using 3.js and ifc.js. Here's the interface, properties, filters, and history. Double-click any beam to pull up its full digital passport. You can filter by level, damage, or repair type. Search for ID 505, and here shows the linked photo. Filter by repair. Click, and they isolate dot or scroll through time. Clicking an event triggers the spatial reasoning, highlighting the entire zone. It turns code into a story anyone can explore. That in the spirit of the Cathedral Preservation Society, we preserve the past, ensuring that this heritage endures for generations to come.